Okay, so let's talk a little bit about databases. So what is a database? In short, a database is a program that is running on your computer or some computer, and its job is to take a message request, you're sending something to it, and its job in essence is to save that data on the file system for the most part. Not always, but for the most part, so that when you turn off your computer or the system goes down or for whatever reason, you don't have that information left in memory. Because let's remember that a computer has two ways of storing information. You can do it in the random access memory, the live memory where all the computations are happening, and that's one place. The problem with storing information there is that once the system goes down, that information is gone, and it's very fast. It's very beneficial if you can keep things in memory like that. It's really great because like you can get at it very quickly. However, because usually you get more data than you can keep in memory at any given time, that's where the file system comes in, which is slower, but that's where you use for long-term storage, and that's where the database comes in. So the database is responsible for making sure that any data that you want to save for a long time is safely tucked away in the file system. And there are many databases on the market that they virtually do the same thing, but they do it in different ways and they have different benefits and consequences. We're not going to dive into all of that. We're just going to look at one database that is fairly easy to get started with and is fairly popular. It's called MongoDB. So if I run the command Mongo on my computer, and I have MongoDB installed. If you want to learn how to install it, they have some great documentation on their website. So I run this, and as you can see now, I'm dropped into a shell. This is actually fairly similar to the Node shell. So if I now run db, the command db just lists the databases that I have I have running right now, right? So just test, as we can see, and that's the only database I need because we're just doing this for demonstration purposes. So that's just a very brief glimpse of what a database is, and we're now going to have a look at what you can do from our application with a database. We're at our Express.js server, and let's just quickly walk through the setup for connecting to a running database on our local system. So we are requiring Express, and then we're requiring this Mongoose. So Mongoose is an npm package that you should install, and basically what it is it's an API or an abstraction layer on top of all the requests and connections and communications that you do with the MongoDB database. So it's just a way to very conveniently from your code get rid of all the different boilerplates and stuff that you would have to do if you wanted to do it like completely from scratch. Like it's the same principle as with Express. I mean, you could do everything yourself, but why do that when somebody has already done it for you, right? So here we are. So we have instantiated Mongoose. Sorry, we've required Mongoose, and now we connect. So MongoDB //localhost, which is my local machine, and here we are /test. This is the name of the database that I want to connect to, and test is the default database that MongoDB ships with. Okay, so now we instantiate our application and we create a schema. So a schema is a data structure for an entity or a piece of data, and to keep things simple, we just want to create a person. So a person object that we can store in our database. So mongo.model person, and here as the second input parameter we state that we want that person data, or that document, to contain a name, and it's going to be of the type string, and that's it. And now we have a person model. So the first two endpoints we're going to look at is getting data and adding data. So we have an endpoint here, which is the root, and what's going to happen is that we're going to go to our model, which is person, and we're going to do .find. An empty object means that I want to find every single person that I have stored in my database. So if I now go to my browser and I refresh this, as you can see that we're actually just getting an empty array. That's all that's coming over the wire. So We're not sending an HTML document, we're not sending anything like that, we're simply sending JSON to our client, to the browser. And if I now want to add something, let's go and look at how that looks. So this is obviously for demonstration purposes, but if I do /add, we can see here that I create a new person's object here, and I set the name to Frederick, put that in a variable, and then I do me.save with a callback function that takes an error. So if there's an error, I'll simply return that error. Otherwise, I will return the JSON response of saving that document, like that person. Now, I go over here, I do /add, bam. And here I see what the database has done. So it's returning a JSON object. I can see that my name Frederick is here, and then I have an ID here. And this is the ID that the database gave to my piece of data so that I can find it in the future if I want to find it again. And this is some overhead information that MongoDB adds to your data. You don't have to worry about that. That has to do with like document versions and so forth. Anyway, so if I now go back and I say, give me all the users, I expect to see, yeah, there's a single person in my database. So this list here that contains all of the people that are in my database contains that one. And I can do this again. So I created a second instance of Frederick with a different ID. And now I have two instances of the Frederick object, and you can see that the IDs are different, and that's really important in any database system. Every ID is always going to be completely unique, because you can't have two IDs of the same ID. That would create a collision. But yeah, that's basically how you add and list your data in MongoDB. Now let's say that it doesn't make sense to me to have two instances of the same person. Like, I want to change one of the Fredericks to something else, right? So I can do that through this demo endpoint I've created, which is called update. So here I can see that, okay, so I use the person module, or sorry, the person model, and then I do find one, and then I give it an object, and I say, okay, find me a single person that has the ID property that matches whatever my query ID is. Get that back, and when you have that person, like, unless there's an error, if you see an error, just return that to the user. Otherwise, go and call the update function that is going to change whatever this person's name, the person that matches this ID, that name, set that to whatever the query name is. And, then there's a callback function here. So if there's an error, return the error, otherwise return the updated person. So if we go back, and here we have two Fredericks, and I take this ID here, and I do /update, and I do ID is equal to this ID, and name is equal to foo. Run that, and now I can see that, alright, there was a single OK modification, and this is MongoDB that is simply stating that it could execute my request, right? So I go back to my list view, and I list it, and here we can see that still the same ID, but the name has changed. And that's basically how updating works. I mean, you can do more fancy stuff, but for this little demo, this should be good enough. Now let's say that I want to clear my database. So I just want to remove everything from the database. Well, then I've created a little endpoint here that it's called /remove. And what this is going to do is it's going to look at the person model, call remove, and since we're giving it an empty object, it's going to match all of the documents that I have in my database and remove all of them. So if I go and do /remove, I see this message all users gone, which is the message I was responding with here. So now I expect that if I go back to my list view, yeah, there are no more users in my database. Now, I mean, this is a completely insane query. You would never have this in a real application. I mean, for the most part, when you want to remove something, you don't want to remove your entire database. You want to remove maybe one or two things. But that's just for demoing, how a remove works. If you want to remove a real person, you can do something like _ID matches request query.id. So if I do this now, I could send a ID in my request to the remove endpoint, and then Mongoose will remove the person that matches that ID, and if it doesn't find someone who matches that ID, I'm going to get an error back. And that's basically how you remove stuff.